Somehow we randomly selected the Chicago. Sorry.
All right. Time to get going, I guess. Everybody, welcome to token binding. If that's not what you want to do, go find a Starbucks or something. Yes. All right. Note the note well. Make sure to get your IPR statements in. Hopefully you don't have any. And all right. So we didn't actually include any updates on our existing core documents on the agenda. That's because there isn't actually that much to talk about. The core documents are waiting for chair write-up, and we're going to get to that this week. And then it goes into the ISG queue, and hopefully in a couple of months they will sort of fall out the other end as RFCs.
Yeah, there are some nits that I just sent to the authors, and we'll have a meeting and make sure that all the document numbers actually line up so that when we spin the versions of all the documents, the references actually point to the correct document. So just a little bit of cleanup to hopefully make the later part of the process easier with the IES.
Exactly. So we have two things on our agenda and a bit of open mics. So just randomly we picked Nick to be first, and then Brian. So it's going to be part 0 and 1 RTT, I guess, and Brian talking about terminators afterwards. So do you want to?
So I'm going to be first briefly talking about token binding in TLS 1.3 for 1RTT connections. Then most of this is going to be focusing on my 0RTT draft. I'll do a quick review of the changes from that draft. That's
The resolution of the yeah. Oh yeah, that's exactly what is there any way to no, I can't find it because it. All right.
All right.
So it looks like we can see slides now. Yeah, so one RTT token binding changes from the previous draft. Then can we go to the next slide? That looks like, yes, that is the next slide. Part of it. Or part of it. Okay, so briefly for token binding on TLS 1.3 connections with one RTT connection. Yes. Token binding for one RTT TLS 1.3 connections. In TBNGO, we limited this to TLS 1.2 and earlier. But like to support TLS 1.3, there are some really minor changes to make. I just wanted to get feedback from the group. Should we write up a separate doc? This would be a pretty short draft to cover the changes needed for supporting token binding in TLS 1.3, or can we just roll it into the existing draft that I've been working on for zero RTT connections? The changes are on the server side. The token binding extension goes in encrypted extensions instead of in the server hello. We can clarify the language that the signed value is using TLS 1.3 section 7.5 exporters instead of using the RFC 5705 language. And then if this is a separate draft, I would just include language that since TLS 1.3 requires all new extensions to define their interaction with zero RTT, if it's a separate draft, we can just say that the server must not negotiate both token binding and early data on the same connection unless updated by another draft, that being the zero RTT draft. So are there any opinions one way or another for that?
Lucy Lynch, I would prefer separate drafts.
Okay. I will write up a draft for that and send you.
Absolutely. I mean, yes, you should do what Lucy says.
So to be fair, my opinion on this is also to write up a separate draft for it.
Yeah, Martin Tom said if you need a third voice, yes, write a separate draft. I think it's a small one. And it's not burdened with all of the uncertainty that the other draft will have. Yeah.
Yeah, it seems if there is a lot of discussion on the zero RTT draft, the one RTT draft is going to be very small. As Sean said, it's like going to be 2 pages, 1 page of that's going to be boilerplate. So yeah, unless someone is really excited about writing that draft, I will do that. Okay, next slide. So in the TLS 1.3 zero RTT draft, the changes from the previous draft are right now it uses the same exporter value for the entire connection. I don't think this is an issue that's been resolved on the list or in discussion here. So I have a slide or two at the end so that we can continue to discuss this issue in hopes of approaching consensus at some point, probably not here. I've restricted the use of zero RTT token binding to PSKs that have been issued from a new session ticket, and also the PSK has to be used with the ECDHE key exchange mode. The reasoning here is that a PSK from a new session ticket is limited in time that it can be used for, and with the ECDHE key exchange mode, this means that we should have separate. We should have a new exporter value that's being signed on every single connection. We also get that with the client, and then there's now a TLS extension to negotiate and indicate use of zero RTT token binding. So this is to make it very explicit when we're doing zero RTT token binding versus doing normal token binding. And there was, in an older draft, there was a replay indication extension that's been removed. Next slide.
Before you go, I just wanted to
Yes.
ask a question about the ECDH key exchange. If the client random is causing those PSKs to be different every time, what's the concern?
I would have to go back up my notes to look up why that restriction was added. Hopefully I wrote that down in the security considerations section of the document.
Okay. I'll have a look at the security considerations, but if not,
Okay.
I'll open an issue on that, because that's worrying. If that's
Yeah,
your assertion,
that
then-
shouldn't. Yeah,
I mean, yeah, it should be different on every connection that completes. If the client random is the same on two different connections that complete, we're in not in a happy place.
yes. I think this has to do with possibly a threat model where an attacker has the PSK to use for resumption, but it does not have the ECVH private value that was used on that connection. And no, it's, and I think this is a point that I need to go back and look at.
Yeah.
It is hopefully in the security considerations. I'm not entirely certain about that.
You went through the attacks last time, and I remember that you might have had one. I think I remember the one that you were talking about, and that is, yeah, you break the resumption secret, and you want to make sure that past the 0 RTT that token can't be used.
Yeah, I think there's something like that.
Because the PSK might be the only thing you use to authenticate the connection. Is that right?
That sounds plausible. Yeah, I can't remember the exact details on that one. Okay, so this slide is basically an overview of what the initial handshake looks like when doing 0 RTT token binding. The client advertises token binding in its client hello. The server, in its response when it issues the new session ticket, this is a server that supports 0 RTT token binding, issues a new session ticket with the early data extension, also issues the ticket with the early token binding extension. And if the client doesn't support 0 RTT token binding, it's just going to ignore the early token binding extension in that new session ticket. So next slide, we see what this looks like when the client does not support 0 RTT token binding, but the server possibly does. The client is going to send, so for this example, the client includes token binding because it's willing to negotiate token binding for this extension. It has early data in this example because it's resuming a session where token binding was not previously negotiated. So the client has the option of, I can resume a connection with no token binding, and I'm willing to do that because the session I'm resuming had no token binding previously, or I can negotiate token binding without 0 RTT on the new connection. And in the example here, the server hello responds with the token binding extension because it is doing token binding but not 0 RTT. The server cannot, in this case, also include early token binding in its encrypted extension. Let's say we're going to do try to do early 0 RTT token binding. It would have to have several bugs in its implementation to do that. One, it would have to assume what token binding parameter was being used for that for that 0 RTT token binding, and it would also have to ignore the must in the spec of it can only send the early token binding extension if the client included it in its client hello. So next slide. You see what this looks like when the early data and early token binding is accepted. The server, the client includes early data, early token binding, and token binding extensions. And the server also echoes all of them back. The server cannot send the combination of early data and token binding in its encrypted extensions without also including early token binding. So the rules on the server side are such that the extension isn't like sort of strictly necessary, but it makes it very explicit what is happening here. If the server were to send early data and token binding, then the client would be well within reason to terminate the connection for the server sending an invalid combination there. So I think that these client and server processing rules, which are explained much better in the draft, make it very clear when 0 RTT token binding is and isn't being done. Okay, next slide. So getting into the topic that we started discussing in Seoul and had a little bit of discussion on the mailing list is about switching exporters. Right now in the doc, the current design is that we don't switch any exporters. This is very convenient for doing HTTP because we have a request response pattern where in that initial request we have the bound token that we want. There are some other application protocols where this might not be the way that they'd want to do token binding. An example here is SMTP or IMAP being used with Start TLS. In that TLS connection, the client speaks first, but they never send any token that might be bound in that first flight. So there might be some protocols that would want to use 0RTT on a connection and token binding on a connection, but without doing 0RTT token binding. So I've sort of reached this question of I don't know if we how much support we want to, or how many other application protocols we want to be considering when designing 0RTT token binding, and whether this use case of not sending a bound token in early data falls under 0RTT token binding. So my thoughts on this right now are that like maybe we do need to have application profiles to say this is how you use HTTP with 0RTT token binding, or this is how you use IMAP with Start TLS with token binding, assuming that someone has previously been interested in that work. So let's go on to the next slide. Or does Martin have comments on this slide?
Yeah, so Martin Thompson, I think our general advice is that application protocols will need some sort of profile in order to use 0RTT. This isn't enough of a foot gun that I think you actually want to have the same requirement for 0RTT token binding, okay. And say that protocols that want to use the token binding, not only do they have to specify the use of token binding within that protocol, but they also have to have a separate carve-out for 0RTT if they want to use 0RTT. And you should explicitly have, for HTTP, here are the rules, and here are the things you have to think about. Otherwise, I think we're into very uncertain territory, because yes, there are profiles, but the risk analysis that you do for token binding is different to the one that you do for HTTP in general. And so the combination of those two things is probably something that you want to at least consider. And you might want to set a reasonably low bar for that analysis to happen, but otherwise, yeah. And thankfully, we have HTTP, and all future protocols can consider this in their token binding use. It's not something it's not going to be particularly onerous for. It's not like there's a ton of them out there already using token binding, and they have to retrofit 0RTT. Everyone will have the opportunity.
And you feel comfortable crafting text to that effect?
Yeah, I did.
I think
that's
just skim through the draft. You really do actually need a specific section on using 0RTT token bindings for HTTP, and it's one paragraph essentially, which is do it this way. But that's much nicer. And you're right. If other protocols don't need token binding 0RTT, then they just say don't do it.
Yeah. Or if it's a protocol that never sends any bound tokens in the first flight, they can just say you can do normal token binding after the first flight.
Don't do the 0RTT variant of token binding. That's fine.
Yeah. Okay. So next slide, which should be the last slide. So this is sort of discussing the different options for which exporter to use when. The sort of first option in here is what the draft currently says, which is that you use the, if you successfully negotiated 0RTT token binding, use the early exporter. And this is going to be sort of roughly equivalent to using client certificates with resumption, in that the proof of possession of the private key is effectively that the client had possession of the private key at the beginning of the initial session. You don't gain much meaningful contribution past that time point, which is what you get with client certs. One of the other options that have been discussed is require that the sort of full strength exporter be used for all token binding messages that are sent after the handshake is completed. This sort of it still has the early exporter in use for the first flight, but this pushes things as close as possible in the direction of the security in TV Proto. The biggest issue that I have with this is both very difficult to define. You could have a token binding message that is split across early data. That's somewhere before and somewhere after. We have covered some of this in the previous presentation. And it also is very difficult to implement this due to layering of protocols. And then we could also have some sort of middle ground for this where the exporter is switched at some convenient time that might not be exactly when the handshake completes. In Sol, I was discussing that the client switches as soon as possible or as soon as reasonably convenient. An issue that was brought up with this is the server has no real way of enforcing it. A slight variant of that could be that the server post-handshake, if the early exporter is used, could just send sort of a soft failcode at the application layer, reject it and say, please try again. And then the client would use the correct exporter past that. I think some of the sort of switching exporters is something that could move into, when to switch exporters, something that could be moved into the application profile. And that would, in this case, with the HTTP case of if we use the 402 early code that Mark Thompson is proposing for zero RTT replay in his draft. That could be in the application profile of how to do that, or if the application is such that there's no early data. If there's no bound token in early data, then it just says you always use the full strength exporter. I think that's sort of another option of sort of move that to the application profile. I think, though, that the base zero RTT token binding draft should have some amount of guidance of like you must do at least this much for it. So at this point, I'm looking for more feedback on when should we switch exporters. Is it reasonable to let the application profile make that decision? Is it reasonable for the application profile to make the decision to the point of maybe HTTP choosing, let's just always use the early exporter?
It's about anger. I think providing too many options provides ways to screw this up like even further. I think we should just pick one. I'm for just using the same export, same same exporter for zero RTT and one RTT data. Because if you're willing to accept the risk for zero RTT data, like it doesn't seem very convincing to me that you wouldn't be willing to accept that risk from one RTT data as well. If you didn't want that, then you would have set that extension which says that do not use it. Don't use zero RTT data for things that need token binding.
I see people nodding and sort of raising thumbs. Do you need a hum, or do you need, like, are you?
Yeah, so Martin Thompson, the analysis for client certificates actually convinced me of something else, but I won't talk about that here. The 4XX that we're proposing for too early.
Yep.
I don't see that actually playing in here. And your analysis for client certificates says this is the same guy I was talking to last time. If the PSK was compromised, then maybe it's not, but it's fine. I think you have what you need. If the resumption PSK is compromised, the entire session could be compromised, right? That's what we're talking about.
If the resumption PSK is compromised, you're
relying on the ECDH.
We're relying on the ECDH
yeah.
share as well. So they would.
That makes me far more nervous than this. The fact that we have to rely on using a particular mode of the key exchange makes me far more nervous than this now.
Okay.
Yeah. This is
So this is okay now because there's something worse? I'm not entirely following your logic.
no, not because there's something worse,
Okay.
but because the analysis that he's done, and I've reached the same conclusions independently myself, which is that this is exactly like having a client certificate. And if you think about it in the same terms as client certificates, you can convince yourself that, well, if client certificates are busted, we're screwed. If this is busted, we're screwed in exactly the same way. And, there's been some pretty good analysis of using client certificates, I think. And if this is as good as client certificates, then we're actually doing pretty well. Reusing the early exporter, yeah, and just commit for the whole connection.
So we have one security level using the 0 RTT exporter, which is equivalent to client certificates, and another using the 1 RTT exporter, which is better
Equivalent to
than
using client certificates. It's using the 1 RTT exporter is roughly equivalent to using a client certificate that you provided on this connection. This one is the client certificate was provided on the previous connection. And we have analysis of all of these things with the TLS that works. And if my equivalence is correct, and I'm not sure that it is, but let's not commit to that with money or anything. But but if that equivalence is roughly accurate, and this seems to hold, then and if it doesn't hold, then we have to tear the whole thing down and not use 0 RTT token binding at all. So. We're either doing it or we're not.
Yeah.
And if we're doing it, this is the best way.
It's sort of like a hand wave the equivalence right now, because I'm not a cryptographer, to do that assertion to say that signing this exporter value is the same thing, but yeah, it should be.
Andrei Popov, Microsoft. So the analogy with certificates is interesting, but I don't think it's correct, at least in 2 ways. First of all, client certificates authenticate the user, where the token binding just prevents replay of tokens, hopefully. And secondly, with client certificate, with the client certificate, there is not a replay problem the way it exists with token binding. Like the reason we use token binding is we want to prevent replay, and if replay is not prevented, then token binding is meaningless. So we should take those 2 differences into account. But I agree that if we have to do token binding with 0 RTT, then we should probably stick with 1 exporter. That's probably the easiest and most kind of practical way.
Okay. So to be clear that I had your 2 points correct, it's you were saying that token binding doesn't authenticate the user in the same way that client certs do, and that second is that using 0 RTT token binding isn't sort of preventing replay of token binding tokens. So I think for the authentication thing, we don't have like a client certificate that has like a subject name in it to say who the user is, but it does say this is the public key that's used. It basically uses the public key as the identity to say, so the server can say, yes, this is the same person that I saw last time with this public key, which is sort of the amount of identity that token binding is providing. For replay, there is the concern that 0 RTT data can be replayed, but I don't think that token binding with 0 RTT isn't designed to prevent the 0 RTT replay concern of TLS. It is what gets replayed is the exact same application data. It still prevents that token being replayed with other application data.
And I believe the reasoning here is the same as our customary reasoning about the termination of the TLS handshake, which is to say that once any data which is received using the keying material after the TLS handshake is completed, is retroactively okay, and in any case that wouldn't be fixed by changing the exporter because the logic is still the same. So I don't think the exporter fixed.
Yeah.
They're not a great set of situations, but I don't think the situations are improved by using different.
Yep. Okay. I don't have anything further to discuss on this. Do we?
I mean, it seems clear that there's consensus in the room around this, so I don't think we need to spend more time on this.
Okay.
All right. Cool. All right. I don't have to like listen to music to watch, but there we are. So Brian gets the high quality presentation, you know, actual screen fit and shit.
I don't know what you want to look at. It's just
Last time we had the slides, cut off my time. And I think you'd step
We
on
can
my-
do that again if you want.
I appreciate it.
Thank you for playing. Sit down.
All right. So HTTPS token binding with TLS terminating reverse proxies. There's a new draft 00 actually just published as 01. I've seen like some super minor little editorial things, but that's the content there. Yeah, thanks for the next slide. So this will be repetitive to some, but I'm going to start from the beginning since we don't have a working group draft yet. Many application deployments with HTTPS have TLS terminated by some kind of reverse proxy sitting in front of the actual application. This happens in all kinds of different environments, from cloud deployment with like a Cloudflare or a Amazon Elastic load balancing, or in internal on-premises deployments where you have an Apache or an Nginx or something, or an F5 terminating TLS. Like it's common across all sorts of deployment environments. Pretty much anything of any significant scale will have this pattern. And for token binding to actually work, at least in the general case of allowing that application to bind against the token binding IDs, some kind of information needs to be communicated from that TLS layer at the terminator back to the application. And without some kind of standard means of doing this, everybody's going to do it differently. And that's exactly what I'm trying to avoid here, because there's all kinds of problems with everybody doing the same thing in different ways. And just as an example of this is kind of the situation we're in currently with client certificate authentication. There's a lot of proxies out there that provide some means of communicating the client certificate to the backend, but they're all a little bit different. And that makes application development and deployment with respect to trying to do certificate auth behind a front end really difficult, or I might say kind of a pain in the ass. So, and it just happens to be I've been dealing with some of that recently, and so it's near and dear to my heart, trying to solve that problem here. So a little bit of confirmation bias. I've been out spreading the good word of token binding to all the people that will listen to my preaching. I would say the most common question I get from people is, okay, that's great, that sounds really cool. What happens if my application isn't the thing that's terminating TLS? Like, how is this going to work? And so if people are aware of it, they're concerned about it, they're looking for a solution to it in the possibility that they actually want to deploy token binding. They see this as a hurdle to adoption. Next slide, please. So I want to give just a little bit of history here, sort of context. So I think I violated some core tenet of IETF protocol in Seoul, and I presented on a draft that did not yet exist, just sort of the concept. But there was, from that, some consensus to at least work on the problem. And there's kind of two general ways to solve this problem, or at least two general ideas about how to convey the information. One is you expose the token binding IDs to the backend application. The other is that you expose the EKM, maybe a little other stuff, to the backend application, and let it do its thing. My sense in the room in Seoul, and maybe I was wrong, maybe it was the weather, who knows, was that people were preferring the EKM exposure approach. So a few weeks later, I wrote this first draft. I won't go thing that did that, exposed the EKM and a couple other things to the backend application as an HTTP header. During that time, somewhere, Jeff Hodges was nice enough to coin the acronym TTRP, which saved me a lot of typing because I was getting tired of finding TLS terminating reverse proxy and copying and pasting what I was writing. So I appreciate Jeff doing that. Also around that time, I received some pushback both on the list and in person and sort of asynchronously off list from people that were not really too happy with the approach of exposing the EKM and having the backend applications do the actual work of verifying the token binding signature. And this was not from theoretical people. This was from people that were working on plugins for systems that are commonly deployed as reverse proxies in Nginx and Apache to be specific. And in IETF 98 in Chicago, we almost ran out of time. Leif lost my slides. And I gave a very rushed, I actually watched the other day, it was terrible. I was nervous and shaking. Rushed and incoherent presentation the last 5 minutes of the token binding session. And it was also cut off short. There wasn't really time for questions and answers. But after that, I did have an open side meeting later that week. And we sat down with a smaller group and kind of talked through the issues. And there was a clear preference amongst that group to do the other approach, where the TLS terminating reverse proxy does the token binding validation and exposes the token binding IDs to the backend application to do whatever they need to do. And then it took me several months, to write Campbell tokenbind TTRP00, and that does exactly that. It exposes the token binding IDs to the backend as HTTP headers. Next, please. A little bit more detail about how that works. Defines HTTP headers that enable a TTRP and a backend server to function together as a single logical server-side deployment of HTTPS token binding. What happens is this TTRP validates the token binding message from the sec token binding header that we all know and love, and removes it from the dispatch request to the backend application. Assuming it's all valid and all good, it takes the provided token binding ID based before URL encodes it and adds it as a new HTTP header, this provided token binding ID, and adds that to the dispatch request. If in fact there's a referred token binding there, it encodes that as well and adds it as referred token binding ID. There's a...
What are you going to say?
Go ahead.
I have use cases where there's 3 token bindings. So I would much rather have a representation where all of them are just passed through and the client application parses it. I do not like the provided referred because it makes other, numbers 2, 3, 4, and 5 in limbo.
So 2, 3, and 4, and 5 don't exist specified anywhere right now.
No, they exist in token binding protocol, and I can use them.
Conceptually.
And I do.
Okay. Another implicit goal of this is also to make it easy to deploy. And this is a pattern that is already being followed to some extent by a number of applications. And I would really like to avoid complicating things for the sake of, I don't know what your use case is, hypotheticals.
It's not hypotheticals. You could have an ID token going one place and an access token going another place, and the provided token binding is neither of those places. Anyway, my input to you isn't change this. It's make sure that there is a syntax for passing all the token bindings through. Thank you.
So Martin Thompson, that's actually pretty easy. Put commas in.
Well, there's a lot of easy ways to accommodate it from just writing it down. Like I've said before, I'm also trying to facilitate something that's very easy to use and deploy and to see. And this is meant to be a profile that allows for HTTPS token binding, which is the which is the document that's about to go up RFC, that only has definitions around sending and receiving provided and referred token binding. So that was the target of this work.
So I have a question. For a third token binding to be in the token binding header, wouldn't there have to be an extension spec to define what that token binding,
So
whatever that is?
my understanding is that you could put multiple headers in, and there was no prohibition against that in the HTTP spec. If you want to put a prohibition,
there's
in
a single header, but it could
that could be repeated.
I don't believe so.
No.
But the underlying data structure can have one or more token binding.
Right.
So you could have a third type. You could have 7 referred, but the actual usage of those isn't defined anywhere.
So maybe this is too early, but isn't this something that is typical that you solve through, for example, like an AGP header, so that you get something above the HTTP, so you know it comes from the reverse proxy server, the information, instead of putting it in the HTTP header, or as an alternative, like
I'm sorry, where would it go?
AGP header instead. So you're running AGP between the reverse proxy and the application, HTTP to the. So you're terminating HTTP at Apache, and then AGP from Apache to the application server. AGP.
AGP?
Yeah.
I'm not familiar with that. Sorry. Okay. It may be so. In my experience, HTTP is used.
That's the way you typically do, for example, with SAML or anything like that. So you know that information comes from the reverse proxy server instead of coming from the endpoint.
So it might be my ignorance, but
Okay.
But SAML, all the SAML deployments I know of use HTTP between the reverse proxy and the backend, and I do.
Shibra, for example, typically in Apache plugins do the HTTP. It's a lot secure than doing. Well, anyway, I just wonder if that has been part of the thoughts and the answers now.
No, it hasn't. It's been strictly HTTP based because that's what I'm familiar with and that's what I see in deployments.
Howdy, Eric Scorla. I fear I'd just be repeating myself from Chicago, but I'll repeat myself anyway. The sanitized thing seems incredibly sketchy.
So I'm familiar with the feedback and have discussed it again in that side main amongst others. And the consensus here is that the sanitization is the appropriate approach. And furthermore, that it doesn't make sense to define a security mechanism between these two systems specifically for this particular header when there's other headers, other information being passed for the two that's already the responsibility of the front end to do some sanitization and other work. And to introduce a new shared key or some other security function around this particular portion seemed unnecessary.
Okay, well, I guess I'm not really very impressed by a bunch of other people who aren't in the room said this. Like maybe you can make an argument that I find more convincing that didn't rely on that.
Well, the argument is it's explicitly called out as a must in the standard. So if you're going to deploy this, you have to follow the must. I realize there's a possibility that sanitation may be missed, but there's a possibility that any security requirement in any of these standards would be missed. And a bunch of other people in this room does, at least in my view, as I'm trying to write this so it can be deployed and used by application providers, and it is that's consensus.
Okay, I'm looking at someone in this room as opposed to people who weren't in this room.
There were 8 or 10 people in the meeting room in Chicago.
Okay, I guess
most of them were people from this room, so I'm trying to reflect that.
So I'd like to see someone stand up.
Please use the mic. You can skip the line and talk there. And if we can, I'm allowing him to skip you, Nick. I'm sorry.
Piotr Sikora, Google. I was in the meeting.
Can you repeat your name?
Piotr Sikora. You mean removing of the set binding?
To repeat my point from last time, this is something that does not feel safe. If you fail to remove this thing, it is a disaster. And so I think it'd be much better to have a system which a positive control, where you had to demonstrate that you were complying with it, rather than simply remove it.
I think a disaster is back to where we are now with whatever cookies are bound. So I'm not sure it's that.
Completely nullifies the security mechanism.
Yes, that's true. If you don't strip the headers that are required to be stripped. No, that's fair. I'm trying to restate the reasons that we got to where we are now.
So Dirk Baltham's Google, I was in the room, this seemed fine to me, and I guess the reason it seemed fine to me because that's what I'm familiar with. That's how we do things in our server deployments. If there's some idea on the table, how else you could do it, I'm happy to look at it, but this didn't raise any red flags to me as we do this.
My suggestion was to establish a shared key and MAC the data, or for that matter, establish a shared key and shove it in the header in front of it, so that presence of the key is required. Like anything that requires active participation by this device, rather than to be passing through.
Sorry, I'm going to jump in again, Dirk. So, Brian, you were saying you don't want to have like a special mechanism just for this, right? If the reverse proxy to backend was authenticated with some key or something, that would probably be fine with you and wouldn't really affect this write-up.
Absolutely. My expectation is that is the case, and that's spelled out in the security considerations, is that some mechanism therein has to be done. What I think the argument is that's too passive, and that something active specifically around these headers should be employed to make sure that the TTRP doesn't inadvertently let through this header and sort of trick the whole system into receiving a provided token binding ID.
Right. I mean, so to be clear, the basic assumption, which I agree with, is that there's some trusted channel between the TTRP and the real origin server, and so, but then the consequence is, because this is some random new header, the TTRPs aren't configured for this, simply pass it through. And so now you have the problem of any misconfiguration whatsoever, then this doesn't feel safe. And so it's not solved by having a TLS connection. What's solved by is having some mechanism where the TTRP specifically attests to these headers. Now, I hear you say it would be a specific solution to this header, but this is a general problem anytime you have something like this. And so sure, the solution isn't to never solve it. It's to make a generic fix for it. And so to go back to I hate to be designing the microphone, but you establish a shared key, and then it comes in a header that has a list of all the headers that you inserted. I mean, this isn't hard to solve if you actually want to solve it, as opposed to want to deflect it.
But that general solution isn't applicable to just this, and shouldn't be defined in a one-off draft around supporting token binding.
Well, if you'd like to have your draft stall behind a solution for it, I think we could do that.
No, but I'm trying to provide a workable solution within the context of what's already provided. And around sanitizing a specific header, the server-side deployment either knows about token binding or it doesn't. And if it's going to be configured to do this, then it has to support this and sanitize these headers. If it's not doing this, then the client can send these headers and it won't strip it, and the whole system.
No, but you have a distributed system with a pile of load balancers and a pile of backend servers. And if you mix and create any of the load balancers, then you have this problem. And so, so you may not think this is an actual problem.
No, I believe me, I do. I just don't want to put a point solution here for a larger problem, or introduce key management and association between this just for this specific piece.
These keys are, but these keys, the system's already the key management. The systems have your private key, This is really,
but that's not written down anywhere. That's not specified in the draft. The systems have the private key because that's how the deployments are required.
Yeah, so you had a key management system that gave them the private key, and now you're worried at key management.
Yes, yeah, I'm worried about describing key management around a shared symmetric key for one specific application. One specific piece of one application.
So I have a question. Is there another working group that's actually focusing on these sorts of reverse proxies where some general solution, because this, whatever solution would equally apply to TLS certificates and other things that currently are using the method that Brian is recommending.
Yeah.
I think from a deployment point of view, if I get what you're saying, is that for getting F5 and ping and everybody else who's making these things to actually support it, there should be some general mechanism for HMACing these headers that this could fit into,
or something else we invent.
Right.
I'm just like, I don't think it's a reasonable answer to say that because we have to solve some other problem, like the more generic problem, we're just going to go ahead with something that we know is not good. That's like not like an acceptable answer.
But I disagree that it's not good. The proxy is two headers.
I commend the energy in the room, but let's keep some order in the queue management.
This is very quick. What John just said sounds like an action item for security.
Right. I mean, yeah. And I was about to ask that question too. So how many people on the floor right now want to talk about this specific issue? Right. Everybody. Okay, have at it. But let's keep. We're gonna close the mic lines after the people who are standing up and clearly indicating their interest to talk.
Mike Jones, Microsoft. I failed to identify myself before. I was going to respond to something that was said now 15 minutes ago, which is the HTTPS draft only defines provided and referred, which may be true, but protocol defines sec token binding in a way that you can pass multiples. And I just want that to be preserved through any proxy solution.
Okay, I'm aware of that. The proxy is meant not for protocol, but for HTTPS. So that's the target support.
Jeff has a clarification.
Jeff Hodges, what he's talking about is the sec token binding header and the token binding message that it conveys. Right.
And the message can contain 3, 5, 17 token bindings.
Right. But if you're doing HTTPS token binding, it won't.
Joe Salloway, Tableau. I don't, just to talk about that, just to say one thing, I think that it is a problem. I've seen many systems, not sanitize header, not this particular header yet, but, this certificate header, it is a problem. I don't know that you should solve it with this draft, but it's a problem I think would be good to solve. I think it would be an improvement for the community. So that's just.
William Dennis, Google. I guess I don't quite understand the concern here, because if you have a terminating TLS proxy that doesn't support token binding, then it doesn't really matter, because it doesn't support token binding. It just reverts to whatever you had previously. Whereas if you do implement the draft correctly, then you get it. So to me, it seems like a win. I would also like to say that, from a developer point of view, it's good to create something that I think is usable by developers and easily consumable. And so what I really like about what your proposal is, as opposed to any kind of shared key thing, is that it's actually going to be easier for application developers to actually get token binding this way. So I think that's a win. And I think if the result is that more people deploy token binding, with a mild risk that if the terminating proxy thinks it's valid, that they don't get token binding, it seems like a win to me.
About anger. So if we're doing some shared key thing, I'd rather just pass the EKM and stuff down the thing, which is your initial proposal. But not that we should do that, but I'd prefer that approach if we end up going the shared key route.
Correct me if I'm wrong, but there were the same concern, different but similar concerns around that approach as well. There was a desire to have the EKM header protected in the same way.
Right. So that just to clarify, that would be like if the reverse proxy may validate or must validate it as well. and then the backend server can revalidate it if it does not trust the reverse proxy that it's talking to.
I think that the concern about HMACing probably applies equally to both, because if you were a bad guy, you would just lie about what your EKM is if the proxy wasn't sanitizing it. So you'd just be lying about a different thing.
Rich Salzakmai, I think Ecker's comment in the middle of the speech was about, well, you're already trusting this server with your private key. You should therefore be willing to just have a shared secret with it. I think that shows the impedance mismatch. These entities behind these accelerators and offloaders aren't trusting their private key. They're having somebody else do all the nasty work for them so they can just concentrate on the business thing. And they'll do IP level routing and IP level access. And yes, it's not great, but I think this, as spec, is a step along the way to help getting better security on those applications.
So was that an argument that, so I guess the question I wanted to ask, both Ecker as AD and implementers of proxies is whether, if you were given the choice of saying, because, as I think Ecker is telling us as AD, that there's, okay, all right, that's fine. All right, fine. What I heard was that there is significant risk in the IETF process for this thing going forward if we don't provide enough security to protect the headers, right? And if that's true, we might wind up in a situation where, as implementers, you'd be presented with a choice of either implementing a shared secret scheme to protect the header or parsing the EKM. All right. Then it obviously needs clarification.
So let me clarify my position. Now speaking as AD.
All right.
This is a working group decision. I think if you do this is foolish, but if you document the situation correctly, it is a working group decision. So.
Okay. Good. That's fine. I still want to hear from implementers what they actually like, because we don't actually have enough implementers in the room.
Yeah. So, Martin Thompson, I think a lot of this is sort of concentrating on the challenge of doing this, and you're making it a lot harder than it actually needs to be. So the load balancer is already doing this TLS exporter thing, and it does have a shared key with the backend server, which is the shared secret that are negotiated with TLS, and you can use TLS exporters and use that to protect these things. And there is no way that the client could produce anything on its leg that would know what this exporter value is. And so it's really very simple to do this. Your HMAC key is generated by an exporter on that connection. This is something you're doing anyway.
You're not. The client and the TLS terminator are doing exporters. You're not even necessarily doing TLS.
Oh, if you're not doing TLS on that back end, then well.
Why not? It could be in a virtual private network.
Yeah, the point of most of these terminators is that they don't do TLS back to the actual application.
Many of them do. Yeah. Many of them don't. Rich solves it. Yeah, many people do this, but most people buy these things so they don't have to worry about that. And they put the boxes or the reverse proxies in their DMZ, and they have IP firewalls, and they trust that that's going to be enough that once the TLS connection is terminated, plain text in the back end. It's really not great, to be mild. We would all find it really, really horrible and stupid, but if you want this as a way to advance token binding to these applications, then I think this is really the only practical way to do it.
To make another point, like even if they do pass the EKM forward, like how will they get the signature on the EKM? Oh, so this is the comment that you made in the original approach, which is that I believe my understanding was, I've been a while since I read the first draft, but it passes the EKM and the signature of the EKM with public key.
Right. So if I was an attacker and I knew that the reverse proxy wasn't sanitizing the EKM header, I would just add my own EKM. If I
How do
found,
you get the
if I
signature?
got the token binding ID.
How do you get that? Like, I mean,
Well,
that's
there's a bunch
you've
of,
got access to the private key at that point, which is like, that's like your threat model is out there now. So yeah, now token binding threat model is gone.
well, no, you just need access to the public key and the token, and
But it
you
has
need
to
a
sign the
copy
EKM.
of the token binding header from the actual connection. Then you would be able to replay that token binding header through the proxy.
I say you would have forced
because the proxy isn't validating.
So you would
the
force,
signature.
so one threat model I can see is that you would force the client to connect to you, and if he uses the same private key as he uses for another domain, then you could forward your own EKM and your you could forward a signed blob that he gave you.
Well, you would forward the EKM that you got from them along with the token binding ID.
Yes. But that assumes that like the client. Right. I'm assuming that people talk to different people. People talk to different origins with different private keys for token binding. And so, if that assumption is not true, I'm not sure what it is in OAuth or whatever. But if that assumption is not true, then this solution doesn't work. But
So, I mean, William asked how you get in this situation. It's really quite simple. You have a network of load balancers, some of which support this draft and some of which do not. And a network of servers, all of which support this draft. And the servers are confused and think that all the load balancers support this draft. And that's how you get in this situation. And like, I mean, I can't tell you how many conversations we've had in TLS about like data centers which are partially configured in odd ways. And like, we just ran into exactly the situation, like, you know, maybe a month and a half ago with a data center that was serving like half bogus OCSP responses. So it's like incredibly easy to get in the setting where your data center is partially misconfigured. I mean, again, like, you know, it may be the case that there's a considered decision that this is not worth dealing with this case, but it's like not the case that this can't happen.
So let's see if I can dig us out to this. So if I interpret Brian's sort of position is that, well, we've got security consideration language that sort of says you must solve this in some way. I hear Martin saying, well, there is an easy solution if you're actually doing TLS on the inside. And, you know, can we get that spec'd out somewhere? You know, in a venue, in a group, in somewhere in the IETF where it will actually get good review and good feedback from implementers. And I don't think that this is necessarily this group, right? And then Brian can reference it.
Well, I guess I don't feel like an enormous amount of attention has been. I feel like the way this has been dealt with is that I suggested you do something about this, and you went away and said I don't want to do anything about this, and now we're like basically fighting about no real attempt has been made to solve this problem. And so I'd like to say, like, I mean, speaking as a working group member, I'd like to see like some attempt made to actually solve this problem.
Right, and I just proposed a strategy for that, right?
Sure,
right?
But
how does that
like I guess, but like when you say reference it, I want it to be like required, not just like.
No, that's fine. Okay, let's argue about what we do with it once we have it. But I'm thinking about how do we get to the point where we have a document that we can use?
Sure, I think.
So I feel like it's a mischaracterization to say we went away and just decided. I proposed a meeting. I invited everyone on the working group list to come to it. I realize it's not normal, and I summarized the results. And if there's if the working group wants another solution, I'm happy to incorporate that. I personally don't feel it's appropriate or necessary. Though I do understand your concerns. I'm trying to keep this simple and deployable, and I would like for it to be available in a time frame that allows for adoption somewhat coincidental with the actual rollout of token binding. That's my goal here. And yes, we could do all kinds of EKM things between the back end and the front end, but it turns out that getting access to an exporter isn't actually supported on a lot of platforms. And that's one of the difficulties of deploying token binding. So if you move that requirement to the back end application in order to support being simple behind a TLS terminal reverse proxy, then you're not going to get deployment of it. We could have a shared secret between the two that's individually configurable in the computer Mac over it. I feel that that's more than it needs to be, but if that's what the working group is interested in doing, we can pursue that. Right now, it's also just an individual draft.
Sure, but we're about to discuss adoption, right? I assume.
Right, we're absolutely going to discuss adoption, right? And I think it makes sort of that discussion maybe a little bit easier, but I don't think it really matters whether this is a working group document or not, because people are going to implement these kinds of things whether we like it or not, right? So I think it's about sort of providing them with safe tools to make good choices, right?
Well, I mean,
and if there was,
word here, right?
and that sort of gets me back to, I think Brian has just speaking as an individual, Brian has a point in saying that this is a solution to this is a more general problem than just token binding.
I certainly agree with that.
Yeah.
So I think,
my question again, where does that document get created? I mean, it's sort of, I'm almost hearing Martin volunteering to sort of. Yeah.
Sure. Well,
I said almost. Huh?
I mean, I guess
there's a TLS chair in the room. I'm sure we can.
Well, it certainly isn't a TLS. It's certainly not a TLS issue, right?
It's an HTTP issue.
Yeah, I mean, so I guess
tried.
I guess I'm willing to have this conversation at HTTP. That would be useful to people. I mean, that might be where you imagine these solutions are come out of. You know,
hot potato routing, excellent.
Well, no,
but can we? So, where do we have that conversation? Can we have it this week?
Sure.
Well, it doesn't have to be a draft, but somebody could put together a question. Is this interesting enough to do?
Sure. Well, I'm certainly happy to put together a problem set and send it to HTTP.
That'd be fantastic. Yeah, I'll buy anybody a beer who does this.
Piotr Sikoragul. So just to kind of advocate this case and why we abandoned EKM, since I don't think Brian said it. One thing is that with this approach, you just need to support token binding in 3 or 4 proxies and not in all the web frameworks, because otherwise clients need to do it. And B is since the actual token binding negotiation on the TLS layer happens between the proxy and the client and not between the backend application. The backend application may be even unable to decrypt the whatever was negotiated on TLS level. Yeah, and to restate the sanitization, yes, this is not perfect. The generic solution to injecting new headers into proxies is something that's needed, but I don't think that's specific to this draft, and it shouldn't block this draft.
William Dennis, just responding to the concern about the partial rollout, where you have like half the load balances complete and half not. I mean, to me, that's kind of a botched rollout, I guess. And I guess I'm not convinced that we should actually add complexity to sort of solve that problem. And I think the cost of doing that is that then we actually make it a lot harder on the people that will implement this in their applications. So personally, I'd rather see all the complexity in kind of at the operator level, at the data center operator level, so that the applications have the easiest time possible to integrate. And I know for us, like, it's not going to be a problem rolling this out. Like if we do roll it out, rolling it out in one go to the entire L7 load balancer class, I don't see an issue with that. So I guess like if a data center operator is at risk of botching this, then they're at risk of botching it. Maybe they'll botch something else. To me, that's not a reason in and of itself to make it. Respectfully, I understand the concern.
Following up on that, Lucy Lynch, I really appreciate this draft because it exposed 2 interesting problems, one of which is the higher level sanitation in general and solution needed problem. And the other is the back-end operational security of the folks using the proxies. And I think, I'm glad somebody's taking the stage to be, but probably something needs to go to the OPSECs and OPSEC as well. I mean, I think Leif's question about whether or not TLS needs to be deployed on its proxies is a good one. I think the load balancer question also falls in that area. I would ask for working with chairs to take it on.
Take what on?
Talking with the ops aides.
Oh, absolutely. But but I think it actually helps if we have concrete proposals on the table. And Brian has a point. People will deploy these things without TLS. It doesn't really matter what we say they must do or not, right? They will do it. I think the best way, again, the best thing we can do is to provide them with good tools so they can have a safe deployment of these things, right? And to me, it sounds like Martin has proposed a pretty decent sort of option for doing that. Yeah. Right. Right.
Okay.
So, through that slide. The last bullet on here, which wasn't covered here, is that the original token binding message is not provided in the backend. Strips. And this is, I thought this might be somewhat controversial because in the discussion we had in Chicago, there was some feeling that the whole token binding header, the sec token binding header, should be renamed and provided to the backend. Sort of with this idea that it might be needed for something. As I went to write down actually doing that, it felt really inefficient and inelegant to include all this repetitive data that was either a repeat of these two IDs or signature information that would be irrelevant to the backend, or extension data, which I don't know how it's going to be used. And the only concrete extension that I can wrap my head around is X0RTT extension. And that, in fact, would only be appropriate for consumption at the front end itself. So my feeling was just get rid of it, make it simple, provide the application with the content that it's actually going to use so people can use this in the play.
So, yeah, Martin Thompson, I agree with this. If it can't use the information, don't give it to it. What's it going to do with it? Is basically the best that you have there.
Seems like a good
I agree,
idea.
totally. I don't think anyone... If someone can come up with a case for passing more information, then you should make more fields for passing more information. Mike's example of multiple token binding IDs is fine, and I think that's a reasonable request. But he is asking for more token binding IDs. He's not asking for the original token binding message or the extensions or anything like that. If an extension is developed that requires this, then you might have to make a new header field or parameters or whatever. That's easy. I actually got up to say something else. Make these sec dash header fields, and that at least removes some of the problems that you might have. For the same reason that you make a sec token binding, you can make a sec header.
I never really understood why. I mean,
Well,
the clients
I argued against it, but yeah.
Even, I guess, for them, JavaScript client being triggered or something like that.
Yeah.
But I'm fine doing it, but an attacker can always make it out of thin air.
So just this formulation that makes me a little bit worried. TTRP required to sanitize headers. So does it mean that there are no way for the application to know securely that the information comes from the TTRP and not is something forwarded that originated from the client? Or is it a way to just pass information in a way that even if the TTRP does not sanitize anything or completely messes up or fails, the application will know that this information did not originate from the TTRP?
That's been the heated topic of debate for the last, I don't know, half an hour, 20 minutes.
Yeah, I know, but I just wanted to check whether...
The draft as written now requires that the backend application trust the TTRP somehow.
Okay.
It might be IP restrictions, it might be mutually authenticated TLS, it might be it might be basic authentication headers that with a shared secret that's known only between the two. I don't know. It's out of scope as written now.
Okay.
And the TTRP then is required to strip these headers when not appropriate, so to prevent a client from sending them through and injecting them in the back end inappropriately. That's how it's written now. And there's a request, proposal, suggestion that something more active be done.
It's good. I just wasn't sure it was like made out as carefully at this point. Yeah.
Vinodan from Google. Quick question. In the interest of making things really easy for downstream app servers to use, and kind of also in the direction of observing what Mike was talking about, would it make sense to send a SHA-256 series of provided and token bindings as headers, and the whole set token binding as the forwarded version? So that way, simple applications can use it out of the box, and more complex applications can parse the header again.
It's certainly an option. I tried to find a middle ground in the simplicity, and following from the suggestion in, I think it's TV Proto, that the TLS token binding TLS layer should make token binding IDs available as an opaque byte sequence applications. That seemed like the appropriate place to expose that level of detail. I know there's some other applications on this. There's an area in OAuth where the token binding ID itself is used in full, so the backend application would need that. That's not set in stone, it can potentially change. But the ID itself seemed like the most appropriate thing to expose to the back. Certainly it could be some hash. You introduce the need then for algorithm agility, which I hope to avoid. I don't know how to answer that. Yes, it might make sense. Those are some of the reasons I didn't do it that way.
All right, so it seems that the back end needs to know the token binding ID, what the token binding type is, provided, referred, or some extension, are essentially the two things that the back end needs to know. So I guess the discussion with Mike is, how do you communicate what that extension is? Because it's not positional. Like the first token binding versus the second token binding in the header doesn't actually mean anything. There is some sort of, you have to register a new token binding type.
So there's all kinds of ways to accommodate that, including going back to just sending the whole thing again. I go back to trying to make this simple and deployable, and I'd like to understand if your use case is around needs of deployers of applications that want to interoperate with each other, or if it's an internal case of Microsoft doing something. Because Tony mentioned recently, or at the last meeting, that he didn't think there was a need for this, which I think implies that Microsoft won't be deploying it, in which case you don't care. If you own all the services, you can do whatever you want. This is intended for facilitating interoperability between independently developed components, be them commercial or open source components.
So Nick Harper, in the token binding message, you can have token bindings of different types, like provided, referred, or types that haven't been defined.
Sure.
But you can have a type repeated multiple times. So you could have, I think we require that there's only one provided, but you could have a list of multiple referred token binding IDs. And in that case, I don't know if any implementations care about the positions of those in the message. Getting back to Martin's point earlier, if you have multiple referred types, that header could just be those IDs separated by commas to support use cases like Mike's with multiple referred token binding IDs.
So at least with respect to multiple referred, I don't recall if that's allowed at the HTTPS layer, but if it is, positionally there's no distinguishing. I mean, I don't know. Actually, to be honest, I don't know. I'm happy to look at solutions for it. I'd love some help with proposed text, but I really want to avoid complicating the. It's not the 80-20 rule. It's probably the 99-1 rule about who will be using this in deployment.
Mindful of the fact that we have 10 minutes left.
Mike Jones, I would be fine with other token binding IDs where there's a list of number and token binding ID.
Okay.
You know, it's for the 10% or the 1%.
We can do something like that. All right, next slide, please. You know, yeah, I got a lot of extra time. Just before this, I mentioned to Nick that I was nervous about presenting. He gave me some spiel about, oh, no, yours isn't the controversial one. You'll be fine. Jinxed me there, I think. So I wanted to provide an example of actual running code. This is a mod token binding Apache module that was updated to support this. I didn't do it. Someone else reading the draft did it. It's really hard to see the technical interface. Makes those available to applications within the Apache context as environment variables. If you want to support this draft in terms of having Apache in front of your applications and HTTP between the two, environment variables, it passes it back. It's really simple and it works. And actually, the guy that wrote this has a little test instance running out there that's publicly available. Included a screenshot of it here, where it was only provided token binding ID negotiated, but it's just in the header. It's all working. It's live. So I was hopeful that would show the simplicity of the approach and that it's easily developed and deployed. Next slide. Maybe. So there are people that want this and deploy it. This is actually from the clock tower. Last time we were in Prague, a bunch of people waiting to see the astronomical clock do its thing. But I thought them waiting for this draft was sort of appropriate too. And I was and I will continue to ask that the working group consider a call for adoption for this draft. I'm not exactly sure what to do about disagreements about the content of the draft before it's even a working group document, or how to proceed with that. I still believe that the problem itself is very important for us to provide some kind of implementable solution for people to do rather than leaving it up to themselves. I suppose there's a couple questions, whether it's this approach or the old EKM approach. I feel like there's more consensus for this approach. There's considerations around additional token binding types, which I think we can get to in whatever approach we take. And then there's questions regarding the security model of protecting these particular headers, which my position I think is pretty clear, but would be part of the process going forward. I think that's summarized.
Yeah, I mean, process-wise, call for adoption is, it just means you turn over change control to the working group, essentially, right? So, and we've already established consensus that the working group thinks that this problem space is worth working on, right? So we've done that already. So I guess it's time to, and it's appropriate at this point to ask for adoption. If you're comfortable with that, we can do that. So in that case, we should do a couple of humps on that. Let's just start with a show of hands. Who has read the last, at least this or the last version, this or the previous version? Oh, that's pretty substantial, actually. Yeah. All right. Who in hum now if you believe that it's appropriate for the working group to adopt this as a working group document? All right, hum now if you do not believe it's appropriate to adopt this document as a working group document. All right, that's pretty straightforward. So resubmit as a working group document, and we'll accept that. Yeah, we can do that, and we'll confirm on the list. But I don't foresee a problem. All right, and then we're gonna, but we are definitely going to get to the issue of how to manage the security requirements for this. So that's definitely something we need to solve. And with that, we are with 6 minutes to go. We are at open mic. if that was your final slide.
That's it.
All right.
Thanks, everyone.
All right. So you made it, Brian. All right. While Brian takes a nap, anybody? Oh,
Yeah.
still on.
So we don't have any minutes left, but still, as we talked about before, is the considering maybe for this group to look into whether token binding should be defined for SAML and whether that what's the best place to do it if it's worth doing. Will it be implemented? I mean, it makes sense in many ways to do token binding for SAML instead of just doing client authenticated TLS, which is done in many other high-level trust framework for SAML. Could token binding be used for SAML? Should be defined here or somewhere else? That's my question.
Let me respond to that question. The way we did token binding for OpenID ID tokens was to use a confirmation element, where the confirmation syntax is explicitly borrowed from SAML. We were not inventing, we were reusing. And so I would suggest that a new SAML token binding hash, TBH, confirmation element be defined, and you use the same token binding hash as ID tokens for JOTs. Who does that? Ask the SSTC or write it down somewhere. I don't have a dog in that fight, but I do think it should be the same as for JOTs.
Jeff Hodges. Agreed with Mike, and yeah, the people who are using SAML, etc., shouldn't
Write it up. All right. So if somebody nudge presents a draft, either here or SSTC, we'll read it and comment, I think, is the answer. So I don't see a problem necessarily. I know that there is very little energy left in the SSTC, and if somebody presented a draft here, I don't think we're religious about not doing it here. But
Yeah, that's basically the question. If it's worth the while to just try to capture this down in a draft and present it to the group.
Mm-hmm. Yeah. So it sounds like you've got a modicum of support there, Stefan. So.
Lucy Lynch, I have a request for Nick on his draft. In the abstract, you say you can do this. You don't say why you would do this. As somebody coming back to this group after having spent most of the last year on the Nomcom, problem statement that said why you do it, not just that you can, would have been really helpful.
All right. We're done. See you in wherever. So, Singapore. See you in Singapore. Thank you. Or maybe not.
Mm-hmm. There's also some nits that I need to some the
I'll keep asking that.
It's cool. We just need to fix some markets. Probably will have to be another round of all of them to make things get right. So we just want to get that done before we'll go up. I got two of them out. I got another one. So that's this afternoon.
I think it's like that. It's like all headers need to be. What about what? Yeah, and there's usually multiple hoppers. You don't go through one.